Next, exercise 21A, second problem. Left hand side we have to take RHS, we have to prove. LHS secant A minus 1 by secant A plus 1. Here secant A, we have to write in terms of cos. 1 by cos A minus 1 by 1 by cos A plus 1 is equal to, here numerator we have to take LCM. Here cos A 1 minus cos A by, here LCM, denominator LCM cos A. Here 1 plus cos A. Cancel. Denominator cancel. Remaining 1 minus cos A by 1 plus cos A. This is our RHS. LH is equal to RHS and proved. Next problem is 3. 1 by tan A plus cot A is equal to cos A into sin A. Right hand side cos A into sin A we have to prove. So LHS we have to write in terms of sin and cos. LHS we have to consider 1 by tan A plus cot A is equal to 1 by sin. Tan how to write? Sin A by cos A plus cos A by sin A. Denominator we have to take LCM. 1 by cos A into sin A. Here cross multiplication. Sin into sin. Sin square A plus, here cos into cos square A. Here sin square A plus cos square A. Value is 1 using identity. 1 by sin A into cos A. We have to write reciprocal. Sin A into cos A. What is the RHS here? Cos A into sin A. Here cos A into sin A we have to prove RHS. LHS is equal to RHS. Hence proved. Next problem is fourth one. Here tan A minus cot A is equal to 1 minus 2 cos square A by sin A into cos A. Right hand side cos sin terms only have. So LHS we have to change into, in terms of sin and cos only we have to write LHS. Tan A minus cot A is equal to tan sin by cos minus cot A means cos A by sin A. You should take LCM. Cos A into sin A. Here cross multiplication you should do sin into sin, sin square A minus cos into cos, cos square A. Now you have to see RHS. Here denominator sin A into cos A. Here sin A into cos A. No changes. Next numerator sin square A minus cos square A. But our answer is only cos square A. So you should change sin square A in terms of cos. What formula we can use here? Sin square A plus cos square A is equal to 1. Here sin square plus we have to write in terms of cos. Cos we have to send right side. Sin square A is equal to 1 minus cos square A. Substitute there. Here cos square A plus we have to substitute 1 minus cos square. Sin square A plus substitute 1 minus cos square A. Cos square A. Already we have minus cos square A by denominator as it is. 1 minus cos square A 2 times we have 2 cos square A by cos A into sin A. So RHS we proved. LHS is equal to RHS. Next problem is fifth one. Cosecant power 4a minus cosecant square a equal to cot to the power of 4a plus cot square a. LHS values cosecants, RHS cots. So LHS we have to take LHS cosecant we have to write in terms of cot. LHS cosecant power a minus cosecant square a. Here cosecant square a whole square we can write minus cosecant square a. What is the common here? Here cosecant square a 2 times is there. Here cosecant square a. So cosecant square a is the common. Remaining here one more cosecant square a minus 1. What is the formula in terms of cosecant and cot relation? Cosecant square a is equal to 1 plus cot square identity. Already we know identity. 1 plus cot square a equal to cosecant square a. Here cosecant square a plus 1 plus cot square a we can write. Next cosecant square a minus 1 cot square a is equal to cosecant square a plus 1 shift right side minus 1. So these two we have to use here. Cosecant square a plus 1 plus cot square a, cosecant square a minus 1 plus cot square a we have to write. Now we should multiply cot square a into 1, cot square a plus cot square a into cot square a, cot power 4a, RHS value. So LHS is equal to RHS, hence proved.